Hi, hello everyone. Today we will discuss a topic on the forecasting in simple regression analysis. So previous classes we discussed about that how to estimate the parameters or slope or coefficients in simple regression model. So after estimating that we need to forecast the values. For example, they will give the values of x and y values. After find out the estimated the y values, so we need to forecast it. So here we'll do how we can forecast in simple regression analysis. We'll discuss. So as we discussed in the last lecture, that is how we can do the before forecasting only we need to get a and b values. So in order to get a and b values in the regression equation, that is a y is equal to a plus bx. So there are different methods which we will get a and b values. So for example, through normal equation method, you will get a and b value, and another method, so deviation method, you will get a and b values. These are the formulas. There is a here normal equation, this one, and another method is y is equal to a plus bx. So in order to get a, here a is equal y bar minus b x bar. Then b is equal summation small x into y divided by summation small x square. So what is small x here? X minus x bar. Small y is nothing but y minus capital Y bar. So here x square nothing but summation x small x capital X minus x bar whole square. For example, they will give the data like this. For example, if they will give the data x and y values, x value 1, 2, 3, 4, 5, and y values 5, 4, 3, 2, 1. So they will ask sometime they will fit a trend line and forecast. Okay, forecasting. Sometimes they will give the years also. So next module we will discuss in the time series how we can estimate or how we can forecast. Also, in the next module we will discuss. So before knowing that, in simple regression also we will forecast values. So when they will give the data like this x values and y values. So here, as per the normal equation, I have got this value a value and b value. See, once we will check it once, what is a and b value? A is nothing but intercept on constant, b is nothing but slope or coefficient parameters, x is independent variable, y is a dependent variable. So in order to get a and b values, we have gone for a normal equation. That is the first two equation, normal one equation 1, normal equation 2. So here once you enter into the values, for example, in order to get y sum of y value, we need to add all y values. So n into a, anything but n number of samples into a value, then b into sum of x value. Sum of x nothing but total sum of x values. So sum of x into y. So we need to get x into y values. So x into y value. Then after summing up, so we need to take these values. Sum of x value is 35 like this. So a sum of x another 15a plus b sum of x square. So in order to get x square only, x into x square. Then after calculating all the x squares, we need to sum of all the values. So sum of x square is 55. So whatever we get the value, simple we can substitute in the model or in the equations. So after simplifying only, we'll get the b values and a value. Okay, in the previous class we discussed it briefly. So if you not understand, you can go with that previous lecture. So here we got b is equal to -1, and when after getting the b value, simple we substitute the b value in the equation 1 or 2. So if you get if you put b value in the first equation, second equation, a value will come same. Okay, so don't confuse. If you put only in first equation, you will get a value. So don't bother. If you substitute the b value in the second equation also, you will get the a value. Okay, it doesn't matter. So simple, I have substituted b value in the first equation. So here, see, after substituting the b value in the first equation, I got a is equal to 6. Okay, so after getting the a and b value, so we need to write that is y hat. This it looks like cap like. So sometimes we can use a cap also. So y hat. This is y hat symbol. So y hat is nothing but estimated y value. Estimated y value. Also nothing but estimated model value. So y cap is equal to 6 minus b. Minus is nothing but a is equal to 6, b is equal to -1. B is equal to -1. As it is, we can put x. This is estimated model. Fitted model. So we can see that fitted values. So that is called forecasting. So simple, if I take into account y is equal to a plus bx. So here, just a minute. Yeah, now it is clear. Say y cap is equal 6 minus 1 into x. So here, what is x value here? Whatever they have given x value, that is 1 here. Into substitute in the place of x. So here I would take into consider y is equal a is equal 6 minus 1 into what is x value here? 1. This 1 is the x value of this. Okay. Then in order to get simplify is equal 6 minus 1 into 1 1 minus 1, then is equal 6 minus 1 5. So y cap, the first one we got 5, estimate value is 5. Then like this, if you go the same like this, for example, see here, second, y cap is equal 6 minus 1. What is x value here? 2. So instead of x here, we need to put 2. Then is equal 6. 1 minus 1 into 2, 2. Minus into plus minus. Then is equal 6 minus 2, 4. Okay. Then here we need to take put 2. So 4. Then next, see y is equal 6 minus 1. X is equal how much here? Third one, 3. Simple, we can substitute the x values in the place of x. Then simply you can see 6 minus 1 into 3, 3. Then you will get 3. So here you can put 3. Okay. Then you take here. So to increase the size because you are not able to understand. So y is equal 6 minus 1, x is equal to 4. Then how much? Then is equal to 6 minus 1 into 4, 4. Then is equal to 2. Okay. Then here we need to put 2. Then y is equal 6 minus 1 into 5. Then is equal 6 minus 1 into 5, 5. Then you will get only 1. Okay, this is 1. So what is here y cap? That is the estimated value. This is the actual values. So normal y is nothing but actual values. Y hat or estimated y we can call, or predicted y. That is called forecasted values. So this is the forecasting. See here, then we want to see that whether is there any difference between actual value and estimate value. For example, if you take into account, so on the base of some data, so the weather reports, for example, if the rain will fall by tomorrow or day after tomorrow like this, so on the base of the values only they will get A and B values. Okay, so they will substitute they will put the x values in the particular values in the particular equations. So they will get the y value, that is the estimate values. So we want to know that whether is there any difference. That is called in a statistic there is a error. Is there any error between actual value and estimate value? That is called error. Error is nothing but error indicates with E or epsilon is equal y minus y hat. So I'm not able to write here y hat. That's why I'm written in the form of y hat. So don't bother about it. So y hat. The error. So here 5 minus 5. Here I'm going to write that 5 minus 5 is equal to how much? 0. Then 4 minus 4 is equal to 0. Then 3 minus 3 is equal to 0. Then 2 minus 2 is equal to 0. Then 1 minus 1 is equal to 0. So here errors. There is 0, nothing but whatever the estimator is estimated and the actual value is same. Okay, the error is nothing but I'm going to write here. See, error is nothing but error is equal y hat. So I'm going to insert at the y hat symbol. Y hat. So this is not to get small e error is equal y minus y cap. Y minus y cap. That is the error. Okay. So sometimes they will ask that regression line. How we can put regression line? So we need to take observations and actual value and estimate value. So when you draw a diagram, you will get straight line, a straight line. So for example, if you want to know that in Excel, you will get the values. For example, the estimate value and y value. So for example, if you take these two values, to insert a table. See here, you can observe here both lines are same because y value and estimate value. Okay, it's a downward sloping, but see here the both lines are on the same because there is no difference between actual value and estimate value. Okay, that is why sum of error is equal to 0. When you had the error values, for example, if you take here, if you sum of all the values, sum of error is equal to sum of e is equal to 0. When you had that is sum of error is equal to 0. Nothing but whatever the estimator estimated, that value, that is value is equal to actual value. So there is no errors in the particular model. So that when the error sum of error is equal to 0 is a good estimator. Generally, we can call we have discussed about the properties of blue, best linear unbiased estimator. That is okay. If you are not understand, then we will explain again. For example, if you want to know how we can draw the regression line, also we can able to. If it is permits, then I will show you that how we can take. For example, simple here, I'm not able to take here because it is not screen is paused out. So I'm going to show whiteboard. See, for example, if you take into account, okay, so this is a y-axis, this is a x-axis. Okay, so simple here 0. So on the x-axis, you can take that observations 1, 2, 3, or 4, or 5 observations, number of observations. So in the y-axis, you will take the values. Y-axis, you can take the values. So 1, 2, 3, or 4, 5. Okay, so simply you can write 1, 2, 3, 4, 5. Same thing you write here also x values, nothing, number of observations 1, 2, 3, 4, 5. So if you take a number of observation, if you take that value at 1, first observation, you get 5. Okay, you get 5. Here 5. So the second observation you get 4. Third observation you get third. Fourth observation you get 2. Fifth observation you get 1. When you draw the line, when you fit the, if you join all the points, you are going to get the straight line. Okay, so this is, if you take into account, this is called y value, y. Okay, so if you want to draw y cap, estimate values, so estimate values are the same. So here I want to show in the yellow color. See, at first observation is same, second observation is same, 4, third observation third, fourth observation is 4. So if you draw this line also, so it's same. Okay. So here, if you write summation error is equal to 0. So it's a best fit. So we can see that this is a best fit model. Nothing but see, there is no errors. There is no errors. Sometimes if you get how we can find out errors. See, for example, if you take into account the data, for example, y is equal to. See, I'm going to clear it. All right. For example, if you take the values of here. See, for example, I'm going to write it. I'm not able to write here y value. For example, I'm going to put only for observation. That is 3, 4, 7, and 8. Okay. So if you take this y cap value here, 3.5, here 5, here 6, here 7, for example. So we want to know that what is the difference between errors. For example, if you calculate the errors, so I'm going to write here the error, the difference between this y and y cap. So y and y cap is nothing but minus 0.5, and 4 minus 5 minus 1, 7 minus 6 plus 1, 8 minus 1, 1. Okay. If you add this, sum of error is equal to how much you will get? Sum of error is equal to how much? Sum of error is equal to, so pluses are 2, minus are 1.5. So here you will get 0.5. Sum of error is equal to 0.5. So if you want to know that regression line, how we can get it? So I'm going to write a regression line here. See. So as I told you, 0, x, and y. So here x-axis I am going to take number of variables, number of samples, 1, 2, 3, 4. So 1, 2, 3, 4. And on the y-axis you will take the highest value is 8 now. So you will take 2, 4, 6, 8. So here 2, 4, 6, 8. Okay. So the first observation, first we need to draw the while actual values line. So the first observation, how much you got it? 3. So here 3. Okay. Just a minute, I want to change the color. Yeah, 3. Then second observation 4. Third observation 7. 7 here somewhere here. Then fourth observation 8. Okay. Then if you take into account the y cap values, the first observation, what is the 3.5? So somewhere here it may be changes, say 3.5 here above line. Okay. So next one 5. Third one 6. Then fourth one 7. Okay. So here if you see, if you join all the points, see this is a okay. So this is the actual value, this is the estimate value. So blue line is the actual values. Okay. So here we need to write this is a y value. Okay. Then here yeah. So here we need to observe clearly with yellow color. I can go and show. So what is the difference here? 0.5. So the difference is -1 here. See. If you take this a plus 1 difference, this is a, so these are observations, that is error. This is a error. AE is a error. So error 1, error 2, error 3. This is the difference. The difference is called errors. So when you put a graph, so it can be straight line. Okay. So it can be some errors value may be negative, some errors value will positive also. So when you sum up, if it is equal to 0, so you will get sum of e is equal to 0. The sum of it is equal to 0. But when you take into account on the basis sum of e is equal to 0, so you may not get nothing but the result may not be uh, incomplete. May not be complete. So that's why some people, in order to get r square value, we need to take into consider sum of not e. So sum of e square, nothing but total sum of squares. Total sum of squares, nothing but sum of squares. Whatever residuals are there, there's errors. So we need to square it. Then only we will get that r square values. Okay, that is 1 minus RSS by TSS. That is 1 minus RSS, nothing but residual sum of square divided by total sum of squares. So that we can get at forecasting. So here, I hope it is understood. If it is not understood, I will clarify your doubts if you have any doubts. Okay, here next one, we need to get the values of here r square. That is r square. R square. So r square formula is 1 minus what is it? RSSS divided by TSS. TSS. So what is TSS here? So one is r square is nothing but coefficient determination. Coefficient of determination. The values lies between 0 to 1. 0 to 1. So if r square 1 of r square is equal to 1, it means that the 100% explanation or the 100% variation explained by the independent variable. 100% variations in dependent variable explained by the independent variable. So if it r square is equal to 0.6, it means that 60% of the variation explained in dependent variable by independent variables, or 60% of the variation in dependent variable explained by independent variables. So here 1 is nothing but 1 now numerical number. RSS nothing but residuals of sum of squares. Residuals of sum of square by TSS total sum of squares. Total sum of squares. So simply if you want to estimate how much time is left, then we'll check it. Yeah. So if the time permits, we'll do that sum of square also there. See, for example, we got errors. So error squares, SQ. Error square. So we can write E. Square 0 into 0 0 0 into 0 0 0 into 0 0 0 into 0 0 0. Okay, then error square. So sum of squares, when you calculate sum of e squares, you are going to get 0 when you had all the values. So in order to get TSS, total sum of squares, total sum of square is nothing but y minus y cap square, y minus y cap square. So here y minus nothing but actual value of y, and y bar nothing but what is the y average of y values, So here y minus y cap y bar square. SQ I'm writing indirectly. Okay. So y minus y bar square. So what is y here? This one. What is the y bar value? How much you got it when you get the total value is 15 by 3. So 5 minus 3. So I'm going to directly write. See here 5 minus 3 is equal to how much? 2. 2 to 2 4. Okay. So if you want then I will 2 into 2 is equal to 4. Then 4 into 4 minus 3. 1 into 1. 1 into 1. How much? 1. Okay. Then 3 minus 3, 0. 0 to 0, 0. Then 2 minus 3. There is a minus 1. Minus 1 into minus 1. So automatically you will get minus 1 minus plus. This is a 1. So 1 into minus 2, minus 3 to minus 2, minus 2 into minus 2. Then is equal to plus 4. So when you add all these values, you will get the sum of y minus y bar is equal to 10. So if you take into account the sum of y minus y bar whole square okay, so is equal to 10. When you add all this value 10. So when you substitute this formula, see r square is equal to r square is equal to 1 minus rss by tss. So here is equal to 1 minus rss, nothing but residual sum of square. Residual sum of nothing but sum of error squares. So what is how much we got it? 0. 0 by 10. So if you take 1 minus 0 by 10, 0. So then r square is equal to 1. So when r is equal to 1, so what it means that, so here when r square is equal to 1, there is a highest value. There is a coefficient determination value is equal to 1. It means that the model is goodness of it. It means that so 100% of the variation in dependent variable explained by independent variable, that is x. Okay, or else sometimes we like the coefficient determination is equal to 1, that is r square value is equal to 1. It means 100% variation in dependent variable, that is y, explained by independent variable, that is x. Okay, so that's why when we can clearly observe the C 100% variations explained by the independent variables, that is the r square. Okay, so this is the one method. I think it's understood. Okay, we learned about how we can estimate the A and B also, then how we can forecasting. Okay, sometimes they will ask such question, for example, on the basis of this data in the time series. I think here, see. So for example, this is a value. For example, if they will ask if x is equal to 6, x is equal to 6, how much y value? How much y value? So simple here, y is equal to 6 minus 1. The x is equal to how much they are given? 6. Simple 6. So simple is equal 6 minus 6. 1 into 6, 6 is equal to how much? 0. 0. Sometimes they will ask if x is equal to 8, then how much y value? Simple, we can substitute the x value is 8. Then 6 minus 1 into 8, 8. Then y is equal to minus 2, because 6 minus 8, 6 minus 8, that is a minus 2. Y is equal to minus 2. This is the forecasting. So simple, in the if the x is equal to something, how much the y value? That is called forecasting. They will ask the question. So on the basis of these values only, we will come to know that how we can calculate the forecasting. Okay. I hope all the students have understood. If you have not understood only, you can ask me in the WhatsApp group, or else if you ask now only, no problem. So thank you, one and all, for your patient listening. So if you like this video, please share, subscribe to get more updates with related to the statistics and econometrics. So once again, thank you very much.